Alright, welcome physical science students. Today we're going to learn about how to make data tables and how to make graphs. So, the first thing we need to do is we need to make a data table. And a data table is just a table or set of columns and rows that organize the data that you collected in an experiment that you did. And it's pretty simple. The simplest one has two columns, and on the left column we write our values for our independent variable. So write down this row here, and again, the independent variable is the thing that you or the scientist that you're reading about changed. The right column is for our dependent variable, and again, that's what changed because of what we changed in the independent variable. Now, once you have made your table, you can fill in data pairs across each row here. So let's do an example. And this example is taken from the lab that we did in class the other day, the Hot Solutions lab. So in the science lab, you are trying to see what effect calcium chloride will have on the temperature of water. Putting in 1 scoop causes a 5-degree temperature increase. 2 scoops causes an 8-degree temperature increase. 3 scoops causes a 10-degree temperature increase. And 4 scoops caused a 19-degree temperature increase. Put this information in a data table. So, again, we're just going to make the simple one here. And I want to cut it in half. And then up in the top here, I want my independent variable to be on the left. Now, I'm not going to write IV. I'm going to write down what the independent variable actually is. So what was actually changed in this lab by the experimenter or by you, that was the number of scoops of calcium chloride. So I'm going to write in here number, or amount rather, of CaCl2. Alright, it's kind of hard to see that. And on the right side, I'm going to put in the temperature increase. Now, normally I'd write this out, but I don't have a lot of room, so I'm abbreviating. Alright, so now I want to make some rows for the data that I collected. And I collected 4 sets of data. The first amount of calcium chloride that I had was 1 scoop. And we had said that 1 scoop causes a 5-degree temperature increase. So I'm going to put 5 degrees right here. We saw that 2 scoops caused an 8-degree temperature increase. 3 scoops was a 10-degree temperature increase. And 4 scoops was a 19-degree temperature increase. So that's our data table. Pretty simple. Alright, so let's move on and talk about graphing. Alright, so when we make a graph, the first thing we want to do is we're just going to make some axes. It's good to, you can start out drawing a picture, kind of gather your thoughts as you're going here. And you might recognize this from math class. We've got an x-axis and a y-axis. And we're going to put the information from our data table onto that axis. Now, step 2 here, we want to make a scale for our variables. If you've seen other graphs, you know that some of them go from 0 to 10, some go from 50 to 150. Again, you can think of any numbers you want, but the question is, how do we know? And so one way that we do that is we can estimate by taking our high value of, say, our independent variable and subtracting our low value of our independent variable and then dividing that number by 5. Now, this is just a arbitrary number, but it gives us good answers. It gives us a good way to make a scale. You do not have to do this, but it's just a way to approximate. If you do this and you end up with a decimal number, either round up or round down, whichever you think makes sense with the data that you have. So, like I said, round your answer to something reasonable. And axes do not have to start at 0. Not all data starts at 0 or near 0. You don't have to start there. That's not a rule. All right, step 3, label your axes. So our independent variable always goes on the x-axis. So our independent variable will go down here, and our dependent variable always goes on the vertical axis, the y-axis. Now we don't put IV and dv, we put down what those things actually are. Step 4, we want to plot our points. So, we may have something that looks like this. And then step 5, we have to decide, is this graph a bar graph or a line graph? And a lot of times I see students just make everything a bar graph or make everything a line graph. And that's not what you're supposed to do. If your x-axis values are continuously increasing, like let's say that this is a number line right here, and it goes 1, 2, 3, 4, 5, 6. Each value is just an increase of the other one. It's a continuous set of data. In that case, you want to use a line graph. But let's say that the x-axis is made up of different items, like different kinds of food or different brands of toilet paper or paper towel. That should be a bar graph. If I'm comparing burritos to oranges and then to chocolate bars, those three things have nothing to do with each other. A chocolate bar is not just more oranges. A burrito is not more chocolate candy bars. They're completely different things, therefore they should not be connected in a line. They should be bar graphs. Now, 2 more things that you need to do is you need to make a title for your graph, and your title should be in the form of whatever your independent variable is versus your dependent variable. So then, finally, after you've plotted your points and you've done everything else, you can draw a line of best fit or draw in those bars for the bar graph. Okay, so let's do an example. And let's use the example of the data table that we made in the previous example. The number of scoops of calcium chloride and how that affected the temperature change in the solution. Okay, so in this case, the first thing I want to do is I want to make an axis. And I'm just going to sketch this. I'm not going to draw it perfectly. If you're doing this, you can try to be neater than this. Okay, so I've got my x-axis and my y-axis. And I know that on my x-axis, that is where my independent variable goes. And that's the number of scoops of calcium chloride. That's the thing I changed every time. So I'm going to put number scoops of calcium chloride. And on the y-axis, I'm going to put temperature change. And that's in degrees Celsius. Okay, now the next thing I want to do is I want to make a scale. What should my graph go to? Well, let's take a look here. My high value for my x values is 4, my low is 1. All right, now what I said before was let's take our high value, 4 minus 1, and divide that by 5. Okay, so I end up with 3 divided by 5, and that ends up being 0.6. So I don't want to go up by 0.6. That's kind of not a nice round number that we're used to. But we could go up by 0.5s or we could go up by 1s. In this case, I think it looks like it would be pretty reasonable to just go up by 1. And I am going to start at 0 on this one. So I'm going to make a 0 mark here. And then I'm going to make a 1, a 2, a 3, and a 4. All right, so that's the x-axis. Now the y-axis goes from 5 to 19. So let's see what that gives us. So 19, that's my high value minus my low value, which is 5, and I'll divide that by 5. 19 minus 5 is 14, divided by 5, and that's going to be 2.8. Again, I'm not going to go up by 2.8s, but I could go up by 3s. That seems like it might make sense. So I'll go up by 3s until I go over 19. So I'll go 3, 6, 9, 12, 15, 18, 21. So 3, 6, 9, 12, 15, 18, and 21. Again, you don't have to do it exactly this way. If you wanted to go up by 2s or go up by 5s, that's fine. Just do something that is reasonable and makes sense. All right, so now the next step here is we want to plot our points. So at 1 scoop, we had a 5-degree temperature change. So I'm going to mark it at 5. 5 would go right about here. At 2 scoops, I had 8 degrees, so 8 would be right about here. 3 scoops was 10 degrees, so that's going to be a little bit higher. And 4 scoops was 19. It's way up here. Okay, so now that I have plotted my points, the next thing I want to do is decide, should this be a bar graph or a line graph? And so I look at my x-axis. Is this just a set of numbers that keep increasing? And is 2 scoops just more than 1 scoop? And is 3 just more than 2? If that answer is yes, which it is, then this should be a line graph. All right, now, if you look at these points, that does not look like they're going to make a line. I could connect the dots, but that doesn't really show a trend. And there may be issues with how I collected data that show that it may not make a straight line. If your dots look like they're supposed to make a curve that kind of fits most of the points. In this case, I'm going to draw a straight line of best fit. And so what I do is I try to draw a straight line that kind of catches most of those points. You know, one of those points might just be what we call an outlier. So maybe, you know, there was something wrong with me reading at that point. Maybe that's just a bad data value. But this straight line of best fit that I drew shows a pretty good trend of what I think was happening, or what is being done in the experiment, that as you add more scoops of calcium chloride, your temperature changes more and more, and pretty much by the same amount each time. So that, one last thing, I need a title, and so that's my independent variable versus my dependent variable. So my title for this graph would be number of scoops of calcium chloride versus the temperature change in degrees Celsius. So that would be my title. So that would be a good graph. All right, let's do one more example. And this time, let's do a bar graph, just to see what that looks like. I'll get my focusing and zooming skills up to speed here. All right, so Fred wants to see what kind of candy people like the best. He left 4 bowls out. One had peanut M&Ms, one had Hershey's Kisses, one had Reese's Pieces, and the last had Sweet Tarts. After 1 hour, he checked the bowls to see how much candy had been taken. 14 M&Ms had been taken, 22 Hershey's Kisses had been taken, 2 Reese's Pieces had been taken, and 55 Sweet Tarts had been taken. Make a data table and graph for this data. All right, so the first thing is, let's make a data table. Okay, so I'm going to make 2 columns, and on the left side, I need my independent variable. And the independent variable is the thing that Fred changed every time. And what did he change? He changed the kind of candy. So that is going to go right here. And what changed as a result of that? Let's make this a little bit bigger. What changed as a result of that? That was the number of pieces taken. Okay, so let's write down what those actual different kinds of candy were. We had M&Ms. We had Hershey's Kisses. I'm just going to abbreviate that with HK. We had Reese's Pieces. I'll abbreviate that with RP. And we had Sweet Tarts. I'll abbreviate that with ST. And M&Ms, there were 14 of them taken. Hershey's Kisses, there were 22 of those taken. Reese's Pieces, only 2 people took those, and Sweet Tarts, there were 55 taken. So this is my data table for this data. Now, I want to graph that data onto a graph. So let's make an axis here. And on my x-axis, I'm going to put my independent variable. So this is going to be kinds of candy. And I'm just going to mark out different ones. I can't really make a scale for this because they're not numbers. So I'll just make different marks. All right, and then over here, I do have numbers. So I can take my high value, which is 55, and my low value, which is 2. I'll just subtract those. 55 minus 2, that's my range. And then I'll go up by, well, we'll see. 53 divided by 5, that's going to be 10.6. I'm not going up by 10.6s. That doesn't make any sense, but I will go up by 10s. And since I start pretty close to 0, I'll just start at 0. And I'll go 10, 20, 30, 40, and 50. And I should go up one more because I go over that, so 60. All right, so M&M's, there were 14 pieces taken, so that's going to be right about here. Hershey's Kisses, there were 22 of those taken, so that's going to go right about here. Reese's Pieces only had 2. And Sweet Tarts had 55. Now again, if I look at this, I can see I have points. So do I connect those dots? Or do I draw a line of best fit? And the answer to both of those questions is no. Because M&M's and Hershey's Kisses have nothing to do with each other. Reese's Pieces and Hershey's Kisses have nothing to do with each other. I can't just take more of these to make these. They're completely separate things. So in that case, I need to make a bar graph. And so I'll just make a bar here. I'll make a bar up here to that point. A very low bar here for the Reese's Pieces. And then a high bar for Sweet Tarts. Now the last thing I want to do is I want to make a title, and again it takes the form of IV versus DV, so this is going to be titled Kind of Candy versus Number of Pieces Taken. And there's my graph.